All right, so I'm happy to kind of go into more depth or less depth as necessary, I guess. So this is work that we're publishing in kind of natural language processing, information extraction, kind of sort of places that type of computer science research gets published. And one thing I would hope for is that this is going to turn into something that's useful for journalism. It's certainly motivated by lots of problems that we see in kind of this computational data journalism space. And of course, I think a major tension in this area is between, what is a good research problem or where we need to advance things versus what's really practical and useful to use tomorrow. And so we don't have this running on an air-gapped laptop tomorrow, unfortunately. But it would be great to get there. All the information for all the stuff I'm going to talk about is on the web. So, 20 minutes?
Oh, yeah, good.
15, I'm sorry. Great.
All
right. So the general idea for, I think, kind of a lot, this is kind of from the perspective of, we want to be able to analyze a text corpus and say something about the events that underlie it that are going on in the world. And so we can think of, for example, there's some sort of data generation process, there's things happening in society. Somehow people write about them. You can write about them lots of different ways. Maybe people write social media posts about something happening. Maybe people write things in historical texts. Or maybe, currently journalists are writing things. Or maybe citizen journalists, all sorts of things. And then we have some sort of textual data that comes out at the end. And then from this textual data, we like to be able to make some inferences about the real world events that cause them to come about in the first place. And so one example that I've worked on a little bit, and lots of other people have worked on in maybe computer science, NLP sort of worlds, or in political science sort of worlds, is international relations. So if you want to know how often countries, yell at each other, or conduct military actions or things like that, this might be something that's really interesting and important to understand if you want to do, say, social science with international relations, or you want to be able to do intelligence analysis, journalism, international relations, things like that. And it turns out the best record for a lot of these things is actually in news reports. It's a reasonable place to get started to get a lot of useful information from. And so one thing that's pretty interesting is being able to try to infer the different types of events that are happening between, say, pairs of countries in kind of like a social network sort of setting. You think of countries as actors. And so for this talk, I'm going to talk about a slightly different problem, but also fits this template of trying to do secondary source analysis of the news. And so, of course, there's police killings. And so I think we're all familiar with police killing civilians in ways in the United States that have come under enormous attention in recent years. And of course, there was kind of a time period where it felt like, Eric Garner, for example, and where we had more and more incidents every month. And of course, last summer, in 2016, it was just, there's one shocking incident, and then, even more shocking incident the next day, the one in Minnesota. And so for all these cases, there's a lot of attention on this. A lot of people were thinking about this. And you can also think about this as saying, okay, well, these aren't just anecdotes, but these are individual data points, right? So we should be able to have some sort of records of all these things. And this would be important information to have for, to serve society in some way. If we had this sort of data, we might be able to answer, or ask basic questions such as, are there more or fewer fatalities than there were in a different time period? Is there some sort of racial disparity? Or do we have observational evidence of racial discrimination, which is, complicated, but there's a lot of things you have to do there. But if you had some sort of data, you could get started at looking into this. We could ask policy questions. So, which police departments are better or worse at having safe conduct with civilians? Or what policing strategies are more effective or safe? You could think of this as improving police departments. You could think of this as opposing police. You could do lots of different things. But in all cases, we really need good data to serve the public interest and do some sort of social science or policy making. And I think this kind of fits into the realm of the job of journalism, maybe more broadly. And so the question is, can we download a database of police killings? And so you would think the government should be collecting this sort of information. Governments are good at collecting data. And so actually, someone said in over 2016, Americans actually have no idea about how often police use force because nobody has collected enough data. So this was actually, this is quoting a government official. And it is, of course, our friend, the former FBI Director, James Comey. And so actually late in the Obama administration, there were a lot of initiatives and a lot of discussion about lack of data in police departments. So police in the United States, it's, there's lots of different governmental entities, there's lots of different organizations, there's very different data collection standards. The FBI and the DOJ have had different programs to try to collect and aggregate that data, but there's basically all these holes in it. There's voluntary compliance issues. There's tension about whether police departments want to be completely transparent with all their data. We've seen that controversy for body cameras, et cetera, et cetera. And so even for fatalities, which you think should be kind of the simplest thing you should have information on, adapt to something that's very clear, it's very important, maybe it's justified, maybe it's not, but at least you should have that sort of information. Turns out the US federal government does not have complete comprehensive records on this. And so there's been all sorts of issues, I think, documented really well. And so, for example, this kind of partial compliance issues, you can use these statistical population estimators to show that there's probably massive undercounting of the evidence. And so the Human Rights Data Analysis Group has done really great analysis of this. They're taking different lists of people who are killed. One source says, here's a list of people. Another source says, here's a different list of people. You look at how much they overlap. If they don't overlap very much, that means it's more likely there's an even larger population of things that you missed. And so actually Christian Lung co-authored this section here at the conference right now. And so there's also just lots of questions of, how is the US federal government doing these days? How's the Department of Justice doing for progressive policing reforms? I think, some people might be a little skeptical of this and think, okay, maybe these efforts aren't the perfect way of getting this sort of information. And there's, of course, the whole area of getting better information or better data about policing has come of increased interest from many different perspectives. Another approach that's out there, we won't be working much with this, is to push really hard on voluntary participation. And so the National Justice Database Project at the Center for Policing Equity is leaning really hard into this. And so getting local police departments to cooperate and basically give this sort of information on stops and things like that. And so there's lots of different approaches to getting into this. So what I'm going to talk about is kind of an alternative approach, which looks maybe more like the journalism approach or the external reporting approach. And so this approach says, okay, well, what we're going to do is get our data from news media reports. We're going to use the corpus of lots and lots of news on the web or from various sources that are like the web. And here what we can do is just have people populate the database by manually reading news articles, maybe filtered by keyword search. That's kind of the basic approach here. And this approach has been used by a lot of different projects which have actually worked really hard to construct as comprehensive as possible of these police fatality databases. And so fatalencounters.org has a really nice data set we've been using. The Guardian and the Washington Post are most well known in the journalism world. And sometimes they've collected new data, and there's also aggregation, lots of different sources. This is a very kind of real world event extraction problem. And so I want to combine these things together. And the thing is, it's also just a massive, when you get into this, it's a really massive project. So the Fatal Encounters folks estimate they've read maybe 2 million articles or leads, spend a lot of time on this. And this is a problem where there's a lot of attention to it and people are willing to put time into it. But it's also just a hard problem. And so what we'd like to do is help automate processes that look like this to kind of do re-reporting of information that's in the news. And there's maybe other questions about how to get the news in the first place. But what our project does is we're going to develop a computational approach where our goal is to kind of extract all the fatality records from a news corpus. So here's a bunch of news articles, pick out all the people, and ideally pick out people who are killed by police. And so we're looking a lot in kind of current natural language processing technologies. Unfortunately, the current extractors aren't working the best, and so we try to train models that more directly attack this particular problem, which is in this interesting setting where there's kind of a lot of human effort, or maybe crowdsourced sort of effort to get some sort of labeled data out of it. And so I think there's also a lot of other questions about how does NLP work with social analysis or journalism in general. We can talk about it if we have time. All right, so the general approach is to say, assume that we have some historical data, that people have worked to try to get coverage of at least some of these events that happened in the past. And what we'd like to do is kind of go forward and saying, from a certain time point on, we'd like to take all the news articles that come out here and be able to say, okay, ideally we could fetch all the examples of events where there was a killing event and names of the people who were killed, right, the victims. And that would be ideally the total automation problem. And what we're going to do here is we're going to use a technique called distance supervision for the case where you have some data to begin with. So say maybe you've been doing this historical analysis and doing something manually or semi-automated, and you have a bunch of examples of things that of events that have already occurred. What we're going to do is use this to train a model based on the text and kind of desired outputs to learn what a fatality event looks like in text, and then at runtime, be able to run on new test data and then hopefully extract these sorts of things. So that's kind of the overall goal. And so, in particular, our model is going to look at individual mentions. And so for individual documents with timestamps, and have examples of people, of talking about particular people. The model is going to try to make predictions about the probability. 2 minutes left? Oh, sorry. Okay, try to predict whether fatality happened, and then do an aggregation of the probabilities to decide whether to add it to the database. And so we constructed a pipeline, which we use for experiments, particularly data through 2016, that's downloaded maybe about 1 million news articles from Google News, based on certain keywords from US News, and done a kind of a cascade of kind of standard NLP technologies for supervised data. And so this problem is pretty hard computationally, fortunately or unfortunately. We end up, what's interesting is there's a lot of data, but we're really saying, okay, let's take, there's 24,000 names of just names of people that were mentioned in these types of news articles over the last 3 months of 2016. And we want to kind of identify, ideally, these 250 people who actually were killed by police. And they could be used to add to the database entry. And so, unfortunately, current event extractors aren't great. If you're familiar with F-scores, we're getting like 1%, 5%, 17%, kind of an off-the-shelf system that currently exists for identifying fatalities. We're going to prove that a little bit. We're not going to make it perfect. And the big problem in all these NLP systems is that typically you need things that are kind of in the same domain. You want to have data for the same problem. And so the model, I will skip through some of the technical details here. So the model is basically kind of a two-stage model that identifies sentence-level fatality assertions with a logistic regression type model. And so kind of at the sentence level where the individual name is mentioned, and then does an aggregation about whether a person was killed by police, conditional on this evidence. And that's done with kind of it's called a noisy or rule. And so there's lots of literature on how to use these things in different ways. And so we'll be using mention level models and using a number of NLP tools. One approach is feature engineered logistic regression, which is kind of a major thing in the sort of area of information extraction and event extraction, and also using a type of a neural network called convolutional neural network, which is often good at sentence classification type problems. All right. And so we can also use supervision at the training time, even though we don't know exactly which sentences describe fatality. We just care about constructing the database. So, okay, you can use EM training and leave with neural networks. Happy to talk about that if people are interested. So here's the final results. So the kind of final system I'll focus on is using what we call this hard LR, soft LR. It's one of logistic regression with EM training to be kind of soft about labels at training time. And this is the precision to recall curve at the entity level. So for all the names, it's treated as a ranking problem, which names you want to rank, so that ideally an analyst or a journalist or a citizen journalist could go through them and re-verify whether or not they're correct. And so what we're seeing is, this is a recall for retrieving the entire database. It actually has an upper bound about 57% based on limitations of our data set. So based on how we set up this Google News scraper and ran it over a year-long period, it covers about little more than half of the instances that are actually in fatal encounters. And so that means that fatal encounters people are using a broader data set than Google is. So we talked to them a little bit, and they have a bunch of other sources they kind of pulled in and stuff. And so this can't get all of the examples. It is, however, quite representative, I think, of the sorts of NLP and IE challenges we have to face in order to really make this sort of thing work. And so what we're finding is we're able to get this model at kind of the lower recall levels having decent precision, like 50% precision or something like that. But unfortunately, the higher recall levels are becoming a little more difficult. That's where we currently are now. All right, so to finish up, and so there's lots of interesting examples. You can find lots of kind of the true positive people were killed in this time period. There's lots of cases of things like name mismatches, for example. Someone who was killed, but not by police, but in a situation with similarities. And of course, cases of non-US, of events that happen not the US, events where people are not killed. The sorts of things that NLP algorithms, they're just hard natural language understanding problems. These are examples of, these are the predictions of names for the top ranked names. All right, so to wrap up, so what we're interested in doing is helping advance natural language processing in the direction of acquiring more behavioral data from names. And there's lots of examples of this in different areas: protests, gun violence, European media monitors, and lots of things. And for police fatalities, from the NLP research perspective, I think we should try to it would be great to have natural language processing work more on really practical, important problems. And this could be an example of something that's useful to do. There's been a lot of data collected, and it has some similarities to other problems where we don't have as much data, and we like to have better automated systems. So for example, gun violence is a good one. The data is really poor for lots of complicated, interesting reasons, and extracting from news would help. And so where we are now is we have something, the accuracy is kind of okay, but there's lots of questions about how to make it better, improve it, and I think it's kind of a very exciting area to push forward. But in general, I just want to say this is an example of how we might be able to develop natural language processing to work better for computational journalism. And if people have ideas about how to make this better, or kind of other areas of sort of approaches to be applied, I'd be happy to hear. Right, thanks.
We have a quick question.